Hello everyone, I'm Salar and this is part 14 from my tutorial, a tutorial for writing an operating system for microcontrollers, a real-time operating system. And finally, after 13 parts for prerequisites about programming and talking about GCC, GDB, Makefile, Linux and other things, finally I want to start talking about writing program for microcontrollers. So, but before starting this part, I gave you some wrong information in previous part about GDB. Let's do cd to project and ls. This is the previous part project, and let's make my project. My project is up to date, and let's do debug my executable file and start my project. As you can see, like previous part, it's my code. It's a simple program, and I wanna give you correct information, and I gave you some wrong information in previous part. And what was wrong information? Information about finish. Okay. Now let's do next to line 8. I'm in line 8. Okay, I'm in line 8, and in line 8 I have a function. Multiply 2 by 4. Let's do a step to function. Now I'm in multiply function, and now I want finish from my function. Okay, finish from finish and step out from my function. Another time I'm in line 8. I said when you enter finish and write finish and press enter, you don't have your return value. Okay, but I should say you have return value. Okay, your return value is in this register, and I said you in a wrong way that you don't have return type. Okay, you have your return type, and your return type here is in this register. Okay, but until now and still you have not put the output of your return type to A. Okay, still you have not put the return value in A. Okay, so you need to another time type step. Okay, the multiply 2 by 8 is 2 by 4 is 8. 8 is here return value, but still GDB has not put the output in a variable here. Okay, in a variable. So if another time type step and press enter, now I have the return value in A. Okay, so when you type finish and press enter, you return from your function. You will return from your function, and you have the output value in your register. But with another step, you put the return value in your variable. Okay, so let's do it from this debug and cd to home directory. I'm in home directory. Okay, now I wanna start talking about writing program for microcontrollers. Okay, in this course, writing an real-time operating system for microcontroller, I wanna write my program for cortex-m microcontrollers from ARM. Okay, cortex microcontrollers. Let's do search for ARM company, ARM holding. It's the website of ARM company, and I think you know ARM is a big company and creates some processor. It's not chip manufacturer, and ARM doesn't have foundry for manufacturing chips, but it creates the design of microcontrollers and processor. Okay, I know you see a lot of things about ARM. Okay, let's do open product and go to CPU and neural processing unit, and let's do filter product processor family cortex-m. Okay, for microcontroller. In this course I want to talk about cortex-m microcontrollers, and you can see ARM have some cortex-m microcontrollers. Okay, and in this course I wanna test my project in STM32F746 discovery board. Okay, this is my discovery board, and I will test my project in this board. Okay, if you have another microcontroller or a chip from other companies, for example NXP, Texas Instrument, or other companies, don't worry, because my course cover all cortex-m microcontrollers, and it's not important that if you have, for example, an NXP board, okay, or Texas Instrument board, you should have a board and a chip, or a chip that is based on cortex-m microcontroller. Okay, it's important to have a cortex-m microcontroller, and it's not important if you have a cortex-m microcontroller from other companies. Okay, so I wanna start programming for cortex-m microcontroller, but before that, until now I've done all of my project in this course for my PC. Okay, for example, I write all of my project and code for my laptop and my PC. Okay, with GCC, and GCC have an good option, and it's dump machine. Okay, dump machine. If you write GCC dash dump machine, you have an output, and it says that with GCC you can write program for x86 64-bit architectural Intel processor, Intel 64-bit processor. Okay, Intel and AMD processor. Okay, and you should have Linux game operating system. Okay, so until now I've written all of my program for my laptop with GCC, and GCC can create executable file for these types of processor and Linux operating system. Okay, let's do Openzone now. Okay, I write all of my program in my PC. What's the processor of my laptop or PC? Intel, and its architecture known as x86 and 64-bit. And what's my operating system? Linux. Okay, and I've written all of my program until now for my PC. Okay, and what's my PC? Intel x86 64-bit and Linux. Sorry. Okay, so it's known as host machine or platform, okay, and it's known as target machine or platform. Okay, my host machine and target machine are similar, and I've written all of my program in my laptop and my PC for my laptop. Okay, until now I've done my programs in my laptop for my laptop. Okay, in my laptop, host machine is my laptop and for my laptop, and target machine is my laptop. Okay, but since now I wanna write program for microcontrollers. Okay, like before, my host machine is my PC or laptop. Okay, x86 64-bit and Linux, it's my host machine. But in this time my target, it's not my PC, is a microcontroller, cortex-m microcontroller. Okay, what's the architecture of my microcontroller? ARM. And what's the operating system that I want to have in my microcontroller? I have no operating system. Okay, I have no operating system, and it's my target platform. Okay, it's my target platform. When you write program from your PC or for your computer, your target and your host is similar. But when you write for your microcontroller, you write your program in your laptop, but for your microcontroller. So your target and your host is different. We have some terms, for example, when you have no operating system in your target, your programming is bare metal. Okay, so what's bare metal programming? What's bare metal programming? When your target doesn't have operating system. Okay, and I wanna write an operating system, so my board and my chip doesn't have operating system now. Okay, doesn't have no, and I want to write an operating system for that. So when you want to write your program for your microcontroller, you doesn't have your operating system. For example, you doesn't have a Linux operating system, your microcontrollers. Okay, there is another term that is cross-compiling. When your target and your host is different, your programming is cross-compiling. Your compiling is cross-compiling, and your compiler, and you need a cross-compiler. But when you have when your host and target, like here, is identical and it's similar, your programming is hosted or native programming, native compiling. Okay, so GCC is a hosted compiler or native compiler. And what's the host machine? Is my laptop. And my laptop has an Intel processor, and its operating system is Linux. Okay, and if another time write GCC and dump machine, it's some information. The output information is about your target. Okay, it says that your target should be x86-64 processor, for example, an Intel processor, and you should have a Linux on your target. What's the host? The host is my laptop. Okay. So, but since now I wanna write my program in my laptop for my microcontrollers. What's the architecture of my microcontroller? Is ARM, 32-bit ARM. Okay, cortex-m ARM. And what's the operating system of my chip and my microcontroller? Now I don't have an operating system in my microcontroller, so I should download a bare metal and cross compiler for ARM 32-bit cortex-m microcontroller, and the host machine of compiler should be x86 and Linux operating system. Okay, so let's do search for my compiler. If you want to find your GCC compiler, you should type GCC ARM compiler. Okay, in ARM website, arm.com, you should have you should click on this link, and now you are in this page, and in this page you can download your compiler. Make sure to search for GCC ARM compiler, not just ARM compiler, because there is another compiler that its name is ARM compiler, not GCC, and it's not a GNU compiler. Okay, it's another compiler from ARM from ARM company, from ARM processor, and it's a bare metal compiler, bare metal cross compiler, and it's based on LLVM project, not GNU project. Okay, in this course I wanna use GCC from GNU, not ARM compiler, so make sure to search for GCC ARM. Okay, now here is GNU ARM embedded toolchain. Toolchain is all of your tools that you use for compiling and building your program, and for example debugging your program. Okay, so as you can see, it's GNU RM. It means GNU GCC for Cortex R and M microcontroller, but you can use this compiler for ARM Cortex A 32-bit. Okay, just 32-bit. You can't use that for 64-bit ARM. If you want to download compiler for 64-bit, you should go to this link. Okay, GNU A download, and here is compiler for ARM 32-bit and 64-bit. Okay, but in this page, if I press download, you will have some choice for download compiler. Okay, and the last version is here. Okay, it's the last version of your compiler, and I recommend you to download the last version. For example, here GCC ARM non-EABI, okay, Win32. It's for Windows 32-bit host, Windows host. Okay, if you have a Windows operating system, you should download this. Okay, but I have a Linux operating system in my laptop and I need a Linux version. If I scroll down, okay, I have here, I should download this. Okay, I should download this. A GCC compiler for ARM processor, and it's for bare metal programming. Okay, it's for bare metal programming. All of compiler in this page is for bare metal programming. As you can see, here is if you click on overview, here is bare metal development. Okay, bare metal development. And if I press this link, another time I'm in GNU-RM, and all of this compiler is for bare metal programming in this page. But if your host is Windows 32-bit, you should download this. If you have Windows 64-bit or 32-bit, it's not important. You can download this or this. It's a executable and installer file, but it's a zip file. Okay, if you have a Linux operating system in your laptop or your PC, you should download this. Okay, you should download number 3. And if your computer or your PC has ARM processor, okay, your PC has ARM processor. For example, if you have a Raspberry Pi board and you have installed a Linux on your Raspberry Pi, and you want to download a compiler for your Raspberry Pi board, Linux ARM 64-bit. Okay, you should download this. And if you have a Mac operating system, Mac OS X 64-bit, you should download these packages. Okay, it's a tarball package for Mac OS. It's a installer package for Mac OS, and it's the source file of uncompiled source file of your compiler. Okay, so I should download Linux x86-48. Okay, it's my host. Let's download that. And okay, because I downloaded that, I pause and cancel my download. And when you download that, in your download destination directory, in your download destination directory, you should have your file. Okay, GCC ARM non-EABI, and you should download this file, and it's the version. Okay, you can download other versions. The version is not important, but it's better to download last version. So now you should untar and extract your download. Okay, it's tar bzip2. It's a bzip2 file. Okay, so let's do cd2 download ls, and it's my file. I wanna extract my compiler. What's the command? tar -x for extract, v for verbose mode, J for extracting bzip2 file. Okay, because the file extension is bz2, and F for name of file. What's the name of file? GCC ARM. And I wanna extract my compiler folder, compiler directory in my home directory, and with -C and address of your directory, you can set destination directory. If I press enter, the tar command will extract my file, my tar file. Okay, and it takes some time. And Okay, it takes some time to extract all of subfile and subdirectories of your package. Okay, let's take some time to extract all of my. Let's stop my. Okay, now tar has extracted my package, and let's go to home directory and ls. Now I have this directory gcc-arm-non-eabi and version of my compiler. Let's to cd to gcc. This is all of my compiler directories. Let's go home. Here is my compiler. Okay, gcc arm. Okay, but first go to your binary directory, bin directory, and you have all of your compilers and all of your tools and toolchain here. Okay, if I cd to bin directory, now I'm in my home directory, compiler directory, and in binary directory, bin directory. And if I press ls, I have, for example, the arm, for example, these tools for writing C++ program, for C program, creating archive assembly, for example, here for linking, my debugger, and a lot of tools. Okay, here is all of my tools for writing a program for my microcontroller in Linux operating system. Okay, if in this directory I write arm name of my directory here, arm gcc and version. Okay, here is, for example, my gcc, and with this gcc I can write program for my microcontroller, cortex-m microcontroller. Okay, but now let's change directory to home directory. Now I'm in home directory, but if I press R and press tab, I don't it does not complete the name. Or if I press all name of my compiler, for example, arm non-eabi-gcc, arm non-eabi command not found. It can't find. Okay, it can't find my command. This command. Why? Because the directory of this command, it's not in path. Okay, so what's path? Let's see some directories. For example, let's do your file system. Here is my root directory, and go to bin. Okay, binary. For example, you have make dir here. Okay, you have ls here, and you have a lot of your command in this directory. And when you write, for example, mkdir, or for example press ls, your operating system and your terminal will find your command from that directory. Okay, so how can I add my compiler directory to these directories? Before that, let's write echo and path. Okay, $sign and path with capital characters. If I press enter, I will have an output. For example, bin. Okay, root and bin, between colon and colon. It's one of directories that terminal search for your command. Okay, so terminal can find, for example, make directory command from this directory. So how can I add directory of my compiler to path? For that, you should write some line in a special file. What's the file? You should open nano and bash rc .bash rc in your home directory. Okay, it's a hidden file in your home directory. If you open your home and show your hidden file, you have bash rc here. Okay, it's in your home directory. You should open that and add some line in the end of your file. So you should write export name of your directory path equal sign, and between double quote you should write first directory that you want to add to path. What's the directory I want to add? Binary directory that contains all of my tools in path. So properties, what's the directory? Properties, it's my directory. Let's copy that, paste it here, and binary directory. Okay, binary directory. You should add binary end of your. It's address of my directory. It's address of directory that contains all of my tools compiler. Okay, and a column, $, and pass. You want to add this part, this directory address, to your path. Okay, and put in path another time. Okay, write this line in bash rc and save and exit. Okay, now if you want to apply these changes to your terminal, you should close your terminal and reopen your terminal, or write source and name of bash rc file. Okay, to apply these changes to your terminal. Now if I press r dash and press tab, I will have my compiler and gcc version. So when you extract your compiler, add the path of your compiler to pass variable. Okay, now home solar gcc arm non abi update and binary. Okay, it's in path. And if I close that and open that another time, arm dash non gcc. Okay, no input file. To wanna an input file for compiling. So now I have a compiler for writing program for my microcontroller, bare metal programming, and is installed in my computer, in my laptop. Okay, the host of my compiler is Linux and x86, as you can see here. The host, it's the host, and the target is for ARM microcontroller and bare metal. And if I write ARM GCC and another time dump machine, okay, here is ARM non-EABI. It's about target for ARM microcontroller, and it means EABI. It means it's bare metal programming. It's a compiler for bare metal programming. For example, if you open here GNU and download, okay, for cortex-A families, 32-bit and 64-bit. You will have some choice here, for example, for Windows host machine or for Linux host machine. Okay, it's a cross compiler and it's for 32-bit ARM Cortex-A processor and it's a bare metal. But for example, here is Linux target. Here is Linux target. Okay, here is for ARM 64-bit and is Linux target. Okay, and its host is Linux and for example Intel or AMD processor, but the target is Linux but ARM processor. Okay, and all of these compilers based on GNU compiler. Okay, based on GNU compiler. Or for example, you have other compiler for ARM programming, linaro.org, and downloads. Go to this address, press enter, linaro.org, and downloads. And for example, you have some compilers from Linaro here. Here is a Linux targeted compiler. Okay, it's for example 32-bit ARM version 7 Cortex-A, and it's for Linux, but here is bare metal. Okay, here is bare metal. And for example, in bare metal, if you click on binaries, you will have some choice, for example, for Windows or other operating systems. Okay, for some host machines. For example, here is MinGW is for Windows. Okay, the host is Windows and the target is ARM 32-bit Cortex-A bare metal. Okay, when you want to write bare metal, you should download here. But if you have a Linux on your target, for example, if you have a Linux on your Raspberry Pi, you should download this. Okay, for example, you should download this because the process of Raspberry Pi is 64-bit. Raspberry Pi version 3 or version 4. So all of these compilers based on GCC. And you may ask, and you may have question, what is ARM non-EABI? What's this parts? This parts is about your target. Okay, it's not about your host, it's about your target, and it's known as target triplets. Okay, if you search for target triplets in GCC, and for example in GCC you will have some information what's this parts, and if you right click in system type, these three parts, it's about your target. Okay, for example, the first is about your CPU, it's ARM CPU. Second is about company. So what's non-company? For example, assume that a compiler is just for NXP chips, NXP Cortex-M chips. You should have name of your vendor or company here, but this compiler ARM non-EABI, it's for all of chips from all of manufacturers and vendors that based on Cortex-M. Okay, so it's not important you have NXP, STM32, Texas Instruments, Cypress, or other chips. You can use this compiler for those. And EABI, it's a standard about your output file. Okay, I will teach about EABI, application binary interface, in future parts. Okay, but it's about your output. Okay, so it's target triplets, and you can study about target triplets, but it's not important to study about target triplets. If you want to write a compiler or create a new compiler, you should want about these subjects. Okay, but if you are curious about this, you can search for target triplets and study about that. Okay, For example, here is for ARM Cortex-A. For example, here is for your processor should be ARM 64-bit. Your vendor is not important, none. In some compilers, you can ignore this part, vendor compiler. Okay, as you can see, GCC dumb machine. The vendor part is ignored. It's just your processor, CPU, and your system type. Okay, your operating system, and the vendor type is ignored. Okay, or for example, here is for ARM 64-bit big endian. Now you may know about big endian and little endian. It's for little endian programming and it's for big endian programming, but I will talk about big endian and little endian. As its vendor is not important and it's for Linux operating system. Okay, so this name is about your target. In the GCC documentation, it's CPU part, it's vendor part, and it's the system part. And the standard of this name is based on target triplets, GCC target triplets. So now you have a compiler for programming for microcontrollers, and in next part I will start programming with this compiler. Okay, thank you very much and see you soon.